that the astronauts read out.
Gravitational effect of those planets.
Hi, I'm John, and this is NASA Now.
3, 2, 1, drop.
Creating an environment on Earth that truly represents the properties found in outer space is no easy task. We'll visit the Microgravity Research Facility in Cleveland, Ohio, to see what it takes to test objects in a free-fall environment. That's ahead. First, here's what's happening at NASA Now. In March, NASA scientist Don Pettit on board the International Space Station ignited some excitement.
I'm ready to light the flame.
The experiment, known as the Structure and Liftoff Combustion Experiment, or SLICE, is just another example of the unique research projects on board the world's only laboratory in microgravity. Results from the flame test can lead to reduced pollution emissions and more efficient burning by a wide variety of industries here on Earth. Before experiments are conducted on board the International Space Station, many of them are tested in facilities on the ground. But how do you replicate the microgravity conditions found in low Earth orbit? We caught up with Nancy Hall, a research scientist and project manager in the ISS Research Project Office at the NASAâs Glenn Research Center. Nancy gave us a first-hand look at what it takes to get the drop on microgravity science.
Gravity is a force of attraction between two objects, and microgravity is when the effects of gravity are reduced and you are in a free-fall state environment. While still experiencing the Earth's gravity, this is how we're able to conduct microgravity research by using NASA's Glenn's 5.18-second drop tower. NASA is interested in studying microgravity because objects behave differently when the force of gravity is no longer acting on them. There's so many unknowns when you fly an experiment in space. We're not exactly sure how it's going to behave, especially if we're doing something new. We'd like to test it here on the ground first. Plus, it's a lot cheaper to test an experiment, find out, oh, this doesn't work, and then go and change it. The term zero gravity does not exist from a science standpoint. For there to be zero gravity, that would mean there needs to be no mass or nothing else in the universe. Gravity is a force of attraction between two objects. As long as you have two objects in the universe, you will have a force of gravity. And when astronauts floating, it may appear as if there's no gravity, but what's actually happening is the astronauts are in a free fall or in a microgravity environment. This is an example of one of our drop packages. As you can see, it contains some sort of chamber, and depending on whether we're doing a combustion or fluid experiment, that's where the main part of the experiment will reside. Around it are all the different electronics, controls. We also have systems that'll collect data, things like temperature, flow rates, lots of different subsystems here, all connected in one package, and a lot of that information we're able to see in our control room. Once an experiment package has been put together in the drop package, the technician crew and engineering crew will take it and hoist it toward the chamber where it's about to be dropped. And in the process, they're getting ready to evacuate the chamber, because what we want to do is drop the package in a free-fall environment. We don't want the effects of drag to affect the experiment. And then it free falls about 432 feet, and we're able to see how the object behaves without the effect of gravity pulling on the object. A lot of our tests, we're looking at visual data. With the combustion experiment, we're looking at what happens to the flame. How does it propagate? In other words, how does it move? Here on Earth, if you've ever had at a birthday party, you know the traditional shape of a candle flame. It's almost like an hourglass shape. In microgravity, that candle flame is actually circular because you don't have what we call here natural convection. So candles, fires behave differently. So we want to understand that. So think about how a smoke detector works here on Earth. Because of gravity, you have the lighter elements rising to the top, and then the cooler air is at the bottom. In microgravity, it's all spherical. You don't have something heavy or lighter. So smoke detectors won't work on the space station. The best part of my jobs is basically seeing an experiment from the beginning, middle, and end, and then seeing it eventually fly on the International Space Station. Just seeing that whole process and seeing the results and thinking that maybe sometime in the future that science experiments, that results may end up helping either someone here on Earth or our efforts to explore the other planets.
You saw how there is some pretty heavy-duty equipment to protect the experiments at the drop tower. Here's an experiment where you can design your own protection to test your object.
Teachers, you and your students can see that no matter how fragile a test object may be, there is a way to keep it intact. Check out Egg Drop Lander on the NASA Explorer School's virtual campus.
Well, that's it for NASA Now. Be sure to visit our Facebook page and leave a comment. We'll see you next time on NASA Now.
NASA Now comes to you from the virtual campus at NASA Explorer Schools.